Hi guys, this week in your fraction chapters, you're going to be reading about several different methods for illustrating the value of a fraction and performing some operations with fractions and just conceptually understanding what fractions are. So many students think of fractions as like the F word in mathematics. They hate to hear it, they don't understand them. If they have any recollection of fractions at all, it's usually about algorithms or how to perform those operations. If they're asked to use fractions in real life, they're very uncomfortable with that. And one thing I hope that really picks up to those of you who really feel like a procedural understanding is better is that once you go out into the real world, if you're an engineer, if you're a statistician, if you are anybody who really is going to authentically use mathematics and logical reasoning in your career, you are not going to be doing that procedurally. When one shows up to work at an architecture firm or in the engineering office, you're not handed a worksheet of problems. You are given a task to solve, and it's important that you understand how to do that. And that's the goal of educating children, is to prepare them to walk into the workforce and do those kinds of things. If they are unable to conceptually understand what they're doing so that they can apply it in those authentic situations, we really have failed them in terms of education. Okay, so please keep that in mind. That's one of the big purposes of the chapters that we're reading this week, is to talk about how to learn to visualize those fractions and how to make sense of the calculations that we have to do with them. Of course, the algorithms for doing that are also explained in the text, but those are they come after the explanation and not before. Okay, the explanation is not an afterthought; it's the whole big idea of the show. Okay, so one of the things that you read about in the first chapter that you read this week was how to use area, set, or length models to illustrate fractions to students. I use sometimes fraction circles in the classroom a lot. Students struggle with using those more so than they do fraction bars, or you may have used Cuisenaire rods. Counters, in terms of sets, those can be a set of counters. Really, they can be a set of anything. It can be a set of teddy bears, it can be a set of pencils, but just for space and simplicity's sake, most often that's a set of counters. In terms of area, fraction circles, again, are good there, but many people also use grid paper through drawing to represent area models. That's another possibility. So we're going to work through a couple of problems here. We're just going to kind of illustrate which model we might use for each one of these and how we might explain that to a student. Okay, so let's look at the question here. 8 of the students in Ms. Ratcliffe's class had pizza for lunch. If there are 12 students total, what fraction had pizza for lunch? Most people would just want to respond 8/12, which is true if you're thinking of this as a part out of a whole situation. But most of us are going to expect that to be simplified. Now, if you were taught procedurally and you're thinking 8/12, you're going to go, well, both of these are divisible by 4, so 2/3. But what does that mean? Why can this simplify to 2/3? If you can't answer that question other than by saying they're both divisible by 4, then that lets me know you do not have a conceptual understanding of what's happening here. And that is going to lead to problems later on. Okay, so let's start out with how could we show this? I would probably use a set model here because ultimately that's what we're talking about. We're talking about a set of students. Okay, so I would start out by arranging these 12 students. Okay, so I'm going to use my draw option here. And I'm going to show my 12 students. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Sorry, my X's are not coming through really well. Okay, so we have 12 students here, and 8 out of them had pizza for lunch. So we're going to say this group and this group. Okay, so that does show my 8/12. Okay, and for those of you who simplified it procedurally, how does it also show 2/3? Okay, why did being divisible by 4 matter? Because in those groups of 12 students, 4 was the largest number I could put into a group and distribute all of the students equally. Okay, so what we hope to get students to see here is that these are equivalent fractions. Okay, they mean the same thing. 8 out of 12 was worth the same amount of 2 out of 3 groups. Okay, I would have the same number of students if I took 8 out of the whole class or 2 groups out of 3 groups of 4 students. Okay, so that is a set model. When we take a set of individuals, in this case, I used X's. Again, you could also do this with counters. A lot of times, students won't intuitively know how to put these into groups, and that doesn't have to happen when they initially count the counters out. They can also physically model that and see it if they have the individual counters in their hands. That's something that makes using the real life manipulative a little bit more useful than necessarily the just the drawing. Okay, so what have we got here? In the next question, I have a question that states the principal told third graders that 3/8 of the playground would be used for a school garden. Okay, Alicia thought that meant at least half of the playground would be used, whereas Benita thought it would be less than half. Is either of these students correct, or is there another solution? Okay, so again, the first thing I would do is draw out my playground. We're going to assume a rectangle here. And I'm going to split it into eighths because the fraction that we have here is discussing eighths. Ideally, my drawing's not so great. Ideally, we would want this to be perfectly even. So this is one reason why I would suggest, rather than having students draw by hand, when you're wanting them to sort these out, it might help to give them some grid paper. That might be really helpful. And when you are illustrating an example to students, it is absolutely critical that when you are breaking things into equal parts, that they look equal to the student. Okay, if they don't, you don't want to teach them that you can compare parts that are not out of the same whole. Okay, that's very, very important. And sometimes when we do freehand drawings, we inadvertently show students that. That's why on the help feed this week, you will see on some problems where I have particularly written, you cannot use models because we are assuming if you draw these models by hand, they would not be exactly the same. Okay, so that's something to keep in mind whenever you're teaching students. Okay, however, we are adults and we should have some background with fractions, so we're going to assume all 8 of my pieces here are equal. Okay, so how would we illustrate 3/8? 3 out of 8 pieces. So we're going to color those 3 in. Okay. Now, again, because I know where I'm going with this lesson, I have strategically broken my playground. Even though I broke it into 8 pieces, I set it up so that I was comparing essentially 4 pieces to another 4 pieces. As a teacher, it's probably or should be obvious to you why I did that. Because the question that the students are posing is in regards to half of the garden. Since I showed my 8 pieces split into half, okay, what we're doing is we're allowing this visual to really lead the student to the answer we want. Okay, these 4 would be half. Obviously, we don't have half colored in, so this can't be at least half. At least, of course, would mean half or more. So we know Alicia is not correct. Okay, Benita thought it would be less than half. So we're looking at this 4 blocks would be half. We do have 3, which is less than that. So we do have some concept of 3/8 being worth less than half. Now, if you're that person who wants to procedurally take 3 and divide it by 8 and turn it into a decimal, okay, here's what you need to understand. Although procedurally that may work, it does not teach your student why that happens. It does not let them know really the relationship between the part and the whole. Okay. Now, if you're teaching high school and you know for certain that you can back it up with data, not just your opinion, that the student has already mastered that concept, this is a way you could maybe approach that problem. You could think of it as a percentage. But if you are going to teach elementary students, or if you are teaching higher level students who maybe don't yet have this concept down, you can't skip that part. The majority of the reason for that in elementary school is that they have not done fractions yet. They have no concept in their mind of what a decimal is. So you cannot teach elementary students using strategies that are not developmentally appropriate or content that they haven't learned yet. So we have to present this in visual form. Okay, so a model drawing that does help them see. Also, in some of the exercises on the discussion feed where you are asked to order fractions, considering the relationship to the half is very important. At this point, we're not asking the student to know exactly how much of the playground has been used other than it's 3/8. We're not asking them to tell us a percentage. But we do know right now that it's less than half. We can compare it to that. Okay. That's something important to think of. We know it's probably pretty close to half, okay, because we're only 1/8 away from being a half. Right. So let's keep on moving here. This again was an area model. We used a set model here, an area model here, so we probably know what's coming for this last question. And I'm going to go ahead and take it onto a clean page so I have some room to draw. Okay, we have Mary, Harry, and Jose are playing red light, green light. They have moved 1/2, 3/4, and 5/9 respectively of the total distance. Now, if you don't know, respectively just means in order. Since Mary came first there, then she's the one that's moved 1/2. Harry came second, so he's the one that's moved 3/4, and so on. Okay, so which person is closest to the finish line? Now, I've seen some people try to put all of these on the same line. And I would caution you not to do that. Number one, because you're going to have a line that you're going to have to mark off in halves, halves, fourths, and ninths. And you cannot just estimate. Remember, the goal is not just to estimate, it is to illustrate. Obviously, our markings are all going to be estimations, but we want them to sort of be comparable to each other. So if I were going to show this to students, I would use a length model, okay? And I would illustrate the path that they're walking or trying to go for red light, green light, a start line and a finish line. Now, what you notice that I'm doing here is I'm doing my best to make sure that all of these illustrations that I have are equivalent as much as they can possibly be. Okay, my start line starts in the same place for all three and it ends in the same place for all three. Why is that important? Again, this concept of equivalent wholes. We have to know that every person's path is the same length. Otherwise, we would not know how 1/2 and 1/4 compare. A lot of times, this is a very confusing concept for young students. Okay, think about it. If I asked you if you wanted half of a cake or half of a cupcake, who would get more? When students are learning fractions, many of them would say you get the same amount. And we know that's not true. We know that if we were talking about half of a cake, that's probably going to give us more cake to eat than half of a cupcake. Why is that true? Because cakes are usually bigger than cupcakes. So when we're talking about fractionality, okay, it is important that students understand fractions are relative to the whole. The size of a fraction is relative to the whole. You cannot compare fractions unless you know for certain that the whole they originated from is the same, or in what way it's comparable. Okay, so that's a very important thing to think about too. So we're going to start up here with Mary. This is going to be Harry. And this is going to be Jose. Okay, so Mary has moved halfway there. So we're going to estimate somewhere about half. Okay, and then I'm going to kind of sketch that in with a color. So we can see that Mary has gone about this far, and we'll put her name there. Okay. Now, next we have Harry. Okay. And Harry, he has traveled 3/4. So I'm going to break this line into fourths. Okay. And I'm starting out with 2/4, which you notice was the middle. Why did I do that? Because I wanted to make sure 2/4 or 1/2 is comparison to Mary's 1/2 there. If I didn't space these lines out similarly, then it might look like one of the fractions is bigger than the other unintentionally. So again, that's why a lot of times I discourage hand drawing models, because we do have to make sure there is some match and accuracy involved. Okay, so Harry, we know he is going 3/4. So he's going to go all the way up to here, and that's, of course, how far Harry's going to get. Okay, so when we get down to Jose, he sort of has the most difficult line for us to think about. He's going 5 knots. So that means we have to break our line into knots. Okay, so what I do here is I kind of try to target, obviously 4.5 is half of 9. So I want to kind of target that this would be the 4th and the 5th knot. Okay, so this would be the 3rd and the 2nd, okay, and the 1st. Okay, so 1, 2, 3, 4 knots, 5 knots, 6, 7, 8, 9 knots. Again, you notice my lines are not perfectly spaced, but in comparison to each other, I know that they match up okay for what I'm trying to compare. If I were doing this activity with students, I might have a line drawn out. And part of the exercise before we get started, depending on my class, might be having us mark their pathways in halves and in fourths and in ninths. And that's a good place where we can have that conversation of how should they match up. 2/4 should match up with 1/2. Somewhere between 4 and 5 knots should match up with 1/2. And we can talk about why that's true. Okay, so now when we've got Jose, who has completed 5 knots, let's choose a different color for him. Okay, so 1, 2, 3, 4, 5 knots if we go all the way up to here. All right. Now we are looking at what Jose has completed. So if we look at the different comparisons here, we can clearly see that Harry is the closest person to the finish line, right? So again, a lot of students, whenever I'm asking them to compare fractions without calculating, they will draw a line and they will try to mark it off and say, well, look, this one's bigger than this one. That may or may not be true if you have not authentically matched up what you're comparing them with. So make sure if the prompt says that on the discussion feed and you choose to do that problem, that you do not try to draw models where it tells you not to draw models, because they may not be appropriate in every circumstance.